rules. Okay, when we can say a number is divisible, a number is said to be divisible when divided by another number gives integer without any remainder, means the remainder should be 0. Let me take an example for this. Suppose you can take number 24. We can divide, whether we can divide it by 2? Yes, we can divide it by 2, and the quotient is 12 and the remainder will be 0. Like this, we can check any number whether it's divisible by another number or not. If it is divisible, means if you got the remainder as 0, we can say that it is divisible. To check for bigger numbers like 236, like that, if you know the rules, means it's very easy to know we can whether this number 236 is divisible by 2 or not. Okay, let me teach the divisibility rule. I have collected this divisibility rule into portions. Here a box, this box contains the divisibility rule of 2, 4, 8, because there is a relationship between this 2, 4 and 8. This 2 is nothing but 1 times 2. This 4 is nothing but 2 times 2. 2 2s are there. 8 is nothing but 2 times 2 times 3. 2 times 2 times 2. So it is 8. So it's nothing but powers of 2. 2 power 1 is 2. 2 power 2 is 4. And 2 power 3 means you are multiplying 2 3 times. Okay, it's nothing but repeated multiplication. So we can consolidate this 2, 4, 8 at a shot. First, we can see what is the rule for 2. The last digit must be an even number. So before that, we can see what is even number and what is odd number. Okay, even number is nothing but it ends with 2, 4, 6, 8. Even number is nothing but a number which is divisible by 2, means we can say that it is an even number. So it is divisible by 2 means we can say that it is an even number. So it ends with, what is the clue we can know, means it ends with 2, 4, 6, 8 and 0. Okay, if it is not divisible by 2, if it is not divisible by 2 means we can say that it is an odd number. What are the odd numbers we have with us? 1, 3, 5, 7, 9, 11, like that. So alternatively it comes. First one is odd, then even number comes. Then odd, then even number comes. If you see the sequence, means odd and even will occur simultaneously. Okay. So to check whether it is divisible by 2, we have for the divisibility of 2, we have to check what is the thing you have to check. We have to check whether it is an even number or not. So what is the clue for even number? The last digit must be an even number. So let me see an example. 236. Check the last digit. So last digit is an even number. So we can say that yes, it is divisible by 2. Okay, we can go for 4. For 4, what is the divisibility rule? The last 2 digits must be divisible by 4. So the last 2 digits must be divisible by 4, or it may be 0. Maybe 0 means if you take 200, immediately we can see the last 2 digit is 0. So we can say that 2 is divisible by 4. Divisible by 4 immediately. So if you want to check 236, what you have to do? You have to take the last 2 digit. Say the 4th table. For last 2 digits means you can say the 4th table. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 six are 24, 4 sevens are 28, 4 eights are 32, 4 nines are 36. So it is divisible by 4. So we can say that yes, it is divisible by 4. So what is the rule you have to check? You have to check the last 2 digits. If the last 2 digits it's either 0 or divisible by 4, we can say that it is divisible by 4. You can check for very big numbers also. Then we can go for 8. We can go for 8. For 8, what we have to check means we have to check the last 3 digits must be divisible by 8 or either it is 0. So we can conclude if the last 3 digits are 0, we can conclude that it is divisible by 8. Okay, for this number 236, what you have to do? For this number 236, this is the 3-digit number. So you have to check all the 3 digits whether it is divisible by 8 or not. For this thing you can use the divisibility technique. First take the first digit, it's not divisible by 8. So you have to take the last 2 digits, first 2 digits. How many times of 8 is less than or equal to 23 means 3 times of 8. 3 8s are 24 means it's not possible. So 2 times 8. So 2 times 8 is 16. If you subtract downwards, what will happen? 13 minus 6 is 7. Then bring down the 6 down. So how many times of 8 is less than or equal to 78? 9 times of 8 is 72. So here we are getting the remainder, not 0. So we can conclude that it is not divisible. It is not divisible by 8. Okay. So to check the rule for 2, 4, 8. For 2 you have to check the last 2 digits, last digit alone. For 4 you have to check the last 2 digits. For 8 you have to check the last 3 digits. This is the rule for 2, 4 and 8 devices. Okay, then we go for the next thing, which is nothing but 3 and 9. This is nothing but powers of 3. If we multiply 3 one time, it's 3. Multiply 3 2 times, 3 times 3, which is 9. Okay, the same divisibility rule for both this 3 and 9. Here what you have to do is you have to check the sum of the digits. Sum of the digits means consider this same number 236. What are all the digits we have with us here is 2 is a digit, 3 is a digit and 6 is a digit. This is nothing but the sum of the digits. Here what is the rule we have with us? Sum of the digits must be divisible by 3. This is the rule. Okay, sum of the digits must be divisible by 3 or 0. For 9 also the same rule, the sum of the digits must be divisible by 9 or 0. So how can you check this 236 whether it is divisible by 3 or no, 3 or 9? So check for 3. We have to find the sum of the digits. What is the sum of the digits? 2 plus 3 is 5, 5 plus 6 is 11. Again we can take the sum of the digits of this 11. What is 1 plus 1? 1 plus 1 is nothing but 2. So for 2, whether it is divisible by 3 or not, no, it is not in the third table. So you can conclude that this 236 is not divisible by 3. Okay, let me give an example that it is divisible by 3. 234. Let me take this number. Now find the sum of the digits. What is the sum of the digits here? 2 plus 3 plus 4. So 2 plus 3 is 5, 5 plus 4 is 9. Okay, da. Here see 9, it is in the third table. So we can say that 234 is divisible by 3. Okay, let me check for 9. We can take the same example. First see what is the sum of the digits for 236. It is 11. So we can say that it is not divisible by 9. So 236 is not divisible by 9. Again for this number 234. 234 we have to check the sum of the digits. What is 2 plus 3 plus 4? 2 plus 3 plus 4 is 9. 9 is divisible by 9. So 234 is divisible by 9. So we can conclude by checking the sum of the digits. In sum of the digits, we have to know a Vedic max tricks. Vedic max trick. What is the Vedic max trick? If you have a big number like this, 5, 2, 3, 4, 9, 6, like that. So here also taking the sum of the digits is little bit tough. Okay. So to avoid this toughness, what is the thing we can use is, there is a very important trick in Vedic maths, which is nothing but casting of 9. Okay da? Casting of 9. In this casting of 9, what is the thing we have to know is, when we add 9 with any number, let me take 9 plus 1, which is nothing but 10. If you add the digits, what will happen? Add the digits means 1 plus 2, which is 1. So if you take 9 plus 2, what will happen? 9 plus 2 is 11. If you add the digit 1 plus 1, which is again 2. So see, 9 plus 3, what will happen? 9 plus 3 is 12. So 1 plus 2 is 3. See here, adding 9 does not affect the sum of the digits. Adding 9 does not affect the sum of the digit. So with the help of this property of 9, we can cast this 9. Casting of 9 means we can avoid adding 9. Okay, if we take this example, 5, 2, 5, 9, 6, 2, 3, we can avoid adding 9, isn't it? So how can you write 5 plus 2 plus 5 plus 9 plus 6 plus 2 plus 3, isn't it? So we can avoid adding 9 here. Combine 6 and 3, which is also 9. So avoid adding 9 here. Then try to add this 5 plus 2 plus 2. Avoid adding 9. So what is the remaining thing we have with us here? This is 5. So 5 is not divisible. 5 is the sum of the digits. So we can say this 5, 2, 5, 9, 6, 2, 3 is not divisible by 3 or 9. Okay.